My name is George Hathaway, and Andrew has introduced me apparently yesterday. I'm sorry I wasn't able to appear when I was supposed to have appeared, and I take full responsibility for that. However, I hope that this insertion in today's program will be able to enlighten you on this most unusual phenomenon, which we have called the Hutchison Effect, because it really is merely an effect. An effect that is produced by an agglomeration in a very strange setup of a group of technologies, including that of Nikola Tesla and Bob van de Graaff and a few others that have been around for a long time, and that have produced some very unusual phenomenon, some of which some of you saw yesterday, as I say, in a rather cryptic format. I have some view graphs here which I will attempt to follow so that I don't wander. This is a topic that is very conducive to wandering because it brings in all of the most amazing kinds of effects that you'd love to have in your basement, such as material levitating and floating around, being able to break steel bars without even your bare hands, and all sorts of other weird and wonderful things. And so, if you will permit me, I will start off on the view graph side here, and we'll see whether that's set up all right. Just a second. Pharos Technologies was a company formed by myself and a gentleman named Alex Pizarro, who you may have recalled made a presentation at the 1983 Atlanta Second International Symposium on Non-Conventional Energy Technology. Alex talked about one of his pet projects, which was oil and gas discovery by novel means. And we, in 1980, formed a small company, namely this one, Pharos Technologies, to try and promote what we then called the Hutchison Effect. We also termed it in our early presentations LADS, or the Lift and Disruption Technology, system, pardon me, and that's me down at the bottom. This presentation is one that we had created in about 1984 to present to various and sundry parties who were interested in funding potentially this technology. And so some of it is a little out of date, but I will be bringing you up to date as we go along. We'll be talking about the introduction and how we came across it, the visual evidence, some of which you've seen already, physical evidence, which I have here before you. You can fondle and touch it and take a look at it in your bare hands. A possible couple of things to help explain it, perhaps, and I hope that Tom Bearden may be soon in the audience, and I believe he also talked on this yesterday, elucidated some of the things. Potential applications and a research proposal that we had attempted to get going a while ago. The lift and disruption system, or the Hutchison Effect, is primarily two categories of phenomenology, perhaps you could say: propulsive and energetic. The system is capable of inducing lift and translation in bodies of any material. That means it will propel bodies upwards. It will also move them sideways, and there are actually four kinds of trajectories which it's capable of producing, and I will explain those in a second. It also has very strange energetic properties, including, as we say, severely disrupting intermolecular bonds in any material, resulting in catastrophic disruptive fracturing, some of which I have here to show you, causing controlled plastic deformation in metals, which you'll see in the slides, creating unusual aurora-like lighting effects in midair, which you may have seen on the video that was shown yesterday, and which I will repeat again on the monitor. inducing apparent large-scale magnetic monopoles. I put apparent now with double underlining and quotation marks, and I'll attempt to explain that in a second as well. Causing changes in chemical composition of metals, certainly there, the distribution of the chemical content, and other long-range effects, at distances up to around 80 feet away from the central core of the apparatus, all at low power and a distance. And I think maybe I should run the video at this point, and let me see what's next up. No, maybe I'll run this guy first. The system, and I've seen quite a few systems that claim to do unusual things. This is a single entity, even though it's made of many discrete components, that performs a number of strange effects. It has many interrelated parts, unfortunately continually being added to by the inventor. It was developed totally fortuitously by Hutchison, who was experimenting with early AC Tesla systems and static machines, such as a Van de Graaff generator. The earliest explanation was given by a chap named Mel Winfield, who some of you may have seen or heard of, who gave a talk at Dr. Nieper's most recent Congress in Germany. This was last year, I believe. And he suggested that the explanation for the phenomenon was due to a method of making the electromagnetic fields spin or swirl in some unknown way. This was the early explanation. We had 3 phases of development, of which the first phase was in the basement of a house. This was where John Hutchison, when I talk about John, it's John Hutchison, the developer of this thing, the discoverer of it. It was in the basement of a house in Vancouver, British Columbia, Canada. And you will see on the video a collection of experimental apparatus which boggles the mind, and it boggled my mind when I saw it first. That was the phase 0 development, you might say. Phase 1 was when we stepped into the picture and took the equipment from that original location and put it in a more reasonable setting. And phase 2 was where it was prior to, it's another lab, where it was prior to its being dismembered and put into storage by John. The main thing about this technology, apart from its unusual phenomenology, is that it is highly transitory. The phenomena come and go virtually as they please. One has to sit there with this apparatus, as I say, usually from between 6 hours and 6 days before one actually sees something occurring, which makes it virtually impossible to interest someone who would like to try and develop it, to assist in funding, for instance, because you can't assume that someone will sit there who is ready to help develop a technology and wait and wait and wait and wait and wait, and perhaps nothing will happen, perhaps something small will happen. It's unusual to ask someone to wait 6 days for a phenomena that they are interested in perhaps developing commercially, so you can imagine. So we've had some difficulty in the past in getting this thing going. Well, what is this thing in particular? Let me now run the video, and I will try and add the commentary that is missing from it, and you can all crowd around and take a look at the screen. I'll try and elucidate what it is you're going to see. I'll move her back a bit. Probably have to cut the lights. I guess that's all right. I will try and crouch down here and and run a few things. If there's at any point you wish to say, stop, hold that shot, or something, I presume I can do it on this. I'm not sure. Is there a freeze frame on this guy?
A lot of light on the screen.
Yeah. Well, perhaps. Do you need to see me, Electra, in this? You've already got this anyway. You just need the sound. Well, oh, I'm fine here. I can read this. Yeah, I can. Okay. All right. Well, let me turn it on and see what happens. This is a video that I made, and here's John adjusting one of his own Tesla coils.
I'm going to take a little walk.
More or less self-explanatory.
2, 2, 4, possible feet, by the way. We're looking straight into the lab. There's the main control panel.
Right down at the bottom.
Bandograph.
It's here.
Ballast. Fan.
There's a small Tesla coil.
There's the variometer.
Various tank circuits.
Each coil. The smaller choke. Another choke. And a view now of the main power supply area showing the spiral spark gap. Various toroids and other components. Now, fan across the ceiling to the dumbbell-shaped coil.
Double-ended Tesla coil.
DRF coil. Small spark gap. The main ballast. The main Tesla coil with a small variometer behind it.
There's the main Tesla coil there, 4.5 feet high.
Tesla coil. The bottom of the ballast and the bandograph. Here's the bandograph. And finally we have a shot of the bottom, the base of the Tesla coil. With the ring, bronze ring in the primary. With the tubes. And back. And John, you gonna wave to the audience? There's John!
This was taken from 8mm
It's also the big coil.
film again. That's why it's clicking. Light up in a second. There's a better shot. The sound is powered because the apparatus was continuing on. That's see what there. Okay. That's what it sounds like when in operation if you're videotaping it. So, and the rest of this is archival. Let's stop this. As you can tell, you've got to excuse the sound on this because it's blown up by the apparatus itself. Now I'm going to wind this forward to an appropriate spot where we can see a bit more. As you can see, the apparatus is almost laughable in its construction. It is extremely difficult to get around. It was extremely difficult to get around in the first lab. That was the first laboratory that he had in Vancouver. And it was so densely packed with equipment that you couldn't find a place to put your foot. You had to step around all sorts of objects that were put on the floor, things like that. I will give you a schematic diagram and a much neater, cleaner setup diagram on the view graphs to come in just a moment. The bushing that we saw breaking in that, or that we just missed catching in that video, was about steel bushing, annular bushing, about 2 inches in diameter, 1.5 inches in diameter, and about 3 or 4 inches long. John still has that in his lab, and I have some similar things to show as well. Now, the next part of the video will be the famous or infamous video that you saw yesterday, and quite a few of you have seen as well in other areas of the globe, and I will try and explain some of its phenomenology. It starts by John warming up the system, and in order to determine where the optimum place for positioning the test objects, which will either take off or burst apart, he puts coins and little bits of styrofoam and things like that on what he believes is going to be the active area. And you'll see the first thing that happens is a quarter starts to flip and starts to vibrate. He knows that that is then an area that he should concentrate putting his specimens in, and he does so. Then I think we cut to some water in a coffee cup, which appears to be swirling, although it's not. It is merely, the surface is merely rippling by some electromagnetic means. And the coffee cup is dancing around on the top of a yellow milk carton. This also is a way he tries to determine where the field is. Then we cut to, I believe, a flat file about 8 inches long, breaking apart. Now I have with me a file that broke apart. That is one thing that I have mentioned up here as in reference to magnetic monopoles. The file broke into 4 more or less equal length sections, and normally if you break a bar magnet, you know that you break it north-south, 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 so that things tend to stick back together again. In this case, the segments were magnetized the wrong way by some phenomena I do not know, and they repel each other when they're put together. At the breaks, you examine where the breaks are and how it should go back together, and they repel each other. Indicative, possibly, of the existence and the development of large-scale monopolar regions that are of such intensity that they disrupt the material itself. Possibly. It's as reasonable an explanation as I've been able to come up with, or anyone else has. And then the film proceeds to document some lifting phenomena. The objects that are lifted in the first part of this section are on the order of a few pounds, half a pound to a few pounds. All of them, if you watch very carefully, lift off with a twist. They spiral as they lift off, and there has to be a particular geometry with respect to down for them to take off. Some objects, if you lie them like a bar, some objects, if you lie them on their sides, won't take off. If you turn them on their ends, they will take off. The geometrical form of the objects, their composition, and their relationship to, I presume, their environment, the field structure around them that is being created by this odd device, all play a part in how these things take off. Now, I said that there were four main modes of, or four main trajectories that these objects can follow if they do choose to take off. There's a slow looping arc where the objects will basically take off very slowly in a matter of a couple of seconds and loop and fall back somewhere else. Perhaps it's a Coriolis effect. Maybe the Earth is moving underneath as these things take off, and they fall back in a different location. The second type of trajectory is a ballistic takeoff, as if you had a penny in your hand and you whacked it from below and the penny takes off. In other words, there's an impulse of energy at the beginning of the trajectory and there's no further power applied to the lifting. And that hits the ceiling and comes back down. A third method of, or type of trajectory is a powered trajectory where there appears to be continuous application of force, of lifting force. And I have some evidence to back that up, taken from this film, which is an interesting concept in itself. And the fourth is a hovering, where objects just will rise up and sit there hovering. The objects can be of any material whatsoever. They can be sheet metal, they can be wood, styrofoam, lead, copper, zinc, amalgams of things, and they all either take off or they burst apart, or they do nothing. That's 99% of the time they do. Then, following that, I believe, at some point, there's a strange lighting phenomena which occurs as well. This only occurred once, but fortunately occurred while John was filming. By the way, this early film, probably most of which you saw yesterday, was taken by John himself. It was taken in the early hours of the morning back in 1981 or something of that nature. And he was running the camera, and of a sudden a sheet of iridescence descended between the camera, namely himself, and some of the apparatus. And you will see that sheet of light. It has a strange pinkish center to it, and it hovered there for a while and then disappeared. John thought he was hallucinating, naturally, but when we developed the film, it turned out that there was something definitely there. Then we wrap up, or that little video is wrapped up with some heavier objects taking off, including a 19-pound bronze bushing, and water in a cup that's dancing around, the surface of which is being vibrated. There are no ultrasonics or sonic devices in this particular series of experiments. Well, I can get into the setup of it in a second, so I'll shut up and see whether you can remember what I said when we run this segment that you've probably seen before. Let me see whether I've positioned it the right spot. To turn the sound down because there is no sound on this. Here we are, found the center of the field, and this quarter's dancing. There's no magnetic component underneath or over top. There are no field coils underneath or over top or anywhere in within 4 feet. There's the flat file breaking apart, and it actually pushes itself apart at the break. Here's the water. And once again, this was taken by John, not by any professional photographer. That's why its quality is so poor. But this is water in a cup. You can just see a film on it that is not moving. It's simply a surface vibration effect that, I should say simply, it's a vibration effect that is brought on by the by the fields, presumably, that are coalescing at this particular spot. And he uses this to make various adjustments until he finds some position of interest where there's a maximum dancing. And what he adjusts, I will talk about subsequently. But you see this cup, you're looking down on the cup, and the cup is on a milk carton, and it's actually dancing around on the milk carton as well. So you can see it vibrating, bouncing about. There are different modes of interference on the surface. And then I think now we get that quick cut of the sheet of iridescence that hung in the lab, which I've never seen. John is the only one who has seen it and captured it on film, fortunately. And this film was taken at a time when the apparatus was working at its peak. Still took 6 hours to 6 days to determine whether, or to wait for something to happen, but it lifted the best. It broke things apart the best, if you want to use that term. There's this sheet of iridescence. You can just barely see on the original. You can see parts of his lathe, things like that behind it, and this pinkish glow right in the center. It was a sheet, like an auroral sheet. Other interesting things, phenomena about it, it does not move, it doesn't change, it doesn't shimmer. It's a static pattern of light. John sometimes, instead of, this is something I didn't mention, instead of lifting objects off, he will purposely try to destroy them. And in this case, he has a 1/4-inch rat tail file round resting on a plywood base, held down from taking off by 2 plywood pieces on the side, some quarters and things. The thing is glowing white hot, and yet there's no scorching of the wooden plywood pieces that are holding it down. Neither are any of the coins affected. Now this is explainable in terms of RF heating theory, because you can get eddy current heating on the surface, and it's almost cool to the touch very shortly thereafter. Still, it's unusual that there's no conductive heat transfer to the wood. In any event, here's a hovering kind of trajectory, a piece of wood that is just hovering at an angle, a piece of plywood. Here we're trying to get this, I say we, John is trying to get this to float, and he fails. In the next shot, he was trying to get this piece of crescent wrench going and failed, but he got the film box instead to lift off, and eventually it floats around and flaps about. He puts it down again, and then this all takes the space to set all this up for a couple of minutes. I mean, once he gets the phenomena. There it is, the box floating above the plywood. And here's a spoon. It's an aluminum or a steel camping spoon or something like that, held down by a piece of wire, spool of wire, and it flaps away as well. This is about half a pound, D-shaped in cross-section steel bushing, and the whole, he sticks this thing on a board, and the board flaps sometimes trying to take off. And you'll see from time to time there are scorch marks on the board from other experiments. The thing makes fires spontaneously in parts of the lab if you're not careful. Here is a composite piece of material, namely a drill. There's a bunch of components in it, wood and steel. Here is a monkey wrench that does not take off due to its geometry. It just sits there floating, dangling with one edge on the bottom. Now, if you see that quickly, I can't stop this. It does spin when it takes off. Here's a wedge-shaped object which will spin. You'll see it with a left-handed twist as it goes up. Famous left-handed twist if you're a Schauberger fan. This piece you'll see vibrating later on. Here's this same old D-shaped piece taking off. Now here, this wedge-shaped piece was put on its edge, and as it tries to take off on one side, there's not enough power or something, and it flops over to the other side. It tries to take off, it flops over to the other side, and the frequency of vibration here is merely that of of the centroid itself in a merely mechanical frequency. I don't think the frequency of oscillation of this has anything to do with any electrical field frequencies. It's just trying to take off, and if it was magically suspended that way from a pendulum, perhaps it might have that natural oscillating frequency, but nonetheless sits there on its edge. Here we have a 1.5 or 1 1/4 inch diameter copper pipe that is just laying sideways, about 1.5 feet long, I guess 2. And you see a piece of grounding strap in the corner, and away it goes. Sometimes the left end takes off first, sometimes the right end. Here we have more of this guy. And here we have 2 objects more or less in the field, and only one of them will take off. They're more or less the same constitution, both steel, mostly steel, and only one takes off. By the way, is this effectively what you saw yesterday?
Yes, sir.
Okay. Here's a 4-pound shot ball from a mill, a ball mill, and here is a coupling bronze and copper, and soldered to the center, and the heavy end takes off first. Here's more of our friend flapping back and forth. Approximately the real speed. I think this was a little slow when they converted this Super 8 into video. Here's a 19-pound bronze bushing. We have a shot in regular motion, then one in slow motion. Here's the regular motion, and it turns out this slow motion to be a powered lift, and that's one I'm going to analyze for you in a minute. And if it's on its side, it does not take off. It bounces up and down and rolls around and flops off the edge. Here we have a cup full of water. This takes a long time. I'll just start off, and we'll cut the film in a few seconds. As John tunes his various knobs and changes various dials and things like that, the surface of the water starts to, as you saw in the coffee cup shot, starts to ripple, as you can see it does there, and eventually the whole surface breaks apart as if it is trying desperately to take off as well. It forms globules, and the globules take off. The drops take off up to about 1.5 feet above the surface. They fling themselves all over the place, and it's not what I would consider an exciting demonstration, but there's no ultrasonics or sonics involved. Normally you can do this with a number of acoustical methods, but I've never seen it done with purely electromagnetic methods. Anyway, that film goes on and on like that, and I think I'm going to stop right there. And so we can catch our breath and go on to something different. So, where are we here? I've given you a taste of the original lab, primitive, crowded, poor connections, hand-wound coils, no instrumentation. A few other points in there. The first films, the one that I showed you, was done in the basement of a house. Pardon me, the second film. The first one that I showed you, which had my voiceover, was done later in the same location. But the films that have most of the lift were done in this early setup, drawing a maximum of 1.5 kilowatts from house mains continuously. Best lift episodes were in the early lab, etc. There's photographic evidence you just saw. I have some stills of a early lift, which was a saber saw, a hand saber saw, and when John tried to use the saber saw, he found that all of the copper, selectively, all the copper windings had fused together in a glob, both in armature and field coils. Right, independent and qualified witnesses. Here we have an emphasis on the disruption part of this lift and disruption system. Confirmatory physical samples including water, aluminum, iron, steel, molybdenum steel, that should be just molybdenum, wood, copper, bronze, etc., etc. All shapes and sizes and masses, and certain materials being subject to certain influences preferentially, as I tried to indicate, depending on shape and composition and things like that. Let us take a look at some of that confirmatory physical evidence. We have tested various of these pieces that have broken apart for hardness, ductility. We've taken a look on optical microscope on them, and I can go at length into the findings that we have, although I'll go over the most interesting. We have taken SEMs with EDAs to determine the composition at various points. We have had various other and sundry tests on these. Well, what are these things? Physical evidence. I'm trying to zip through this in my allotted time. Now, let's take a look at the slides, and this may give you an idea of the kind of disruption, as we call it, for lack of a better word, that is capable of being produced by this apparatus. And I will describe where all this stuff is in relation to the coils and things like that in a moment. Now, these are two samples of aluminum, one of them which is on the right, which was twisted up, in this case in a right-handed spiral, I guess, and the left, which was blown into little fibers, which the very same one I have here on the table in front of you. Most of this was done in, these specimens were done when we set up the lab in 1983-84. It keeps popping out of focus, I'm afraid. There's a cow magnet that broke, which is not too exciting, but the top one is a molybdenum rod used in nuclear reactors as fuel pins, and those things are supposed to withstand temperatures of about 5,000 degrees centigrade, Fahrenheit. They're from the US. And we were able to watch these things wiggle like this, back and forth, and we stopped the apparatus halfway through a wiggle, and that's the result on the top. The bottom right is a piece of aluminum, cast aluminum piece that burst apart, and the scale is there for you to see. Those are inches. There's more shots of that guy. Looks like we are upside down. That is a nail not suspended from the ceiling, but it's actually standing on its head. And the nail was driven into it was one of the things that John used to hang his coat on or something like that, somewhere another location in the lab, and it melted. It just kind of melted out of the wall, or out of the wood that it was nailed into, and parts of it dripped one on top of the other, and you can see that piece of artwork. It is upside down. You can see it better. This is all right. Now here's a collection of pieces of metal that have been blasted apart or twisted and turned. The largest piece you can see in the background is about 12, 13 inches long. It's 2 inches in diameter. It's a regular steel, and the front edge of it, which you can see, was blasted off about 3/8 of an inch, was completely powdered. The top of it just crumbled like a cookie. And we have fragments that we've analyzed, and they are extremely high anomalously high in silicon, although this wasn't a silicon steel bar. The piece on the right, the tall standing one, I have it here with me. It is about 5 inches or so, 6 inches tall, and about 1.25 inches or so in diameter. It is it's a piece of steel with case hardening around the outside. Case hardening's been blown off at the top, and 3/4 of an inch of it vaporized, basically, into a puff of black smoke, which we could never find the pieces of. Then there are various pieces of aluminum and steel. There's that funny inverted V-shaped thing is a boring bar. If you can straighten it out, it's a boring bar. You can still see the old tool that John was using as a spike through it. And it was on a shelf about 10 feet away from the center of the apparatus, and he did not see this happen. It just bent up into a tight U and deposited a bunch of copper at the bend. Copper seemed to somehow magically come out of solution, if it was ever in solution in the first place, and agglomerate into globs at the break. And I have that piece here to show you if you wish to see it. And various other sundry strange aluminum blastings and smashings. There's that piece again, which basically turns into little fibers of aluminum from the inside. It's a volume effect. It's not merely an eddy current surface effect. It's a volume effect. The whole thing is blasted right through. A bunch of steel bits and things, a drill bit that has twisted multiply on itself. It's continued to to twist. And there's that funny file that broke into 4 sections, and when put together they repel each other, or did, until they've been bashed around so much that it's very difficult to show that now. Anyway, there's same old samples, and there's a large guy and a small guy. And now there's the boring bar on the right, which is no longer of much use, and the piece of aluminum, which is mostly useful as a paperweight at the moment, which I have with me and you can see. So I think that's pretty soon the end of all those guys. By the way, you can just see the copper in the break there. I presume you can see it. Little tiny bits of copper. Down. Which have magically come out of solution, if you can call it a solution, if you presume that metals are actually liquid.
What was that bar to begin with?
It was an inch long, approximately an inch in diameter, 3/4 of an inch, boring. It was just a plain steel rod, tool steel rod, that John was using as a boring bar for his lathe. And it bent up double on itself and broke apart. If we've got any more here. Okay, that's enough of that. You want to turn the projector off to save the bulb for others later? Now you'll have to excuse me whipping through this. Maybe, can you all see that, my view graphs? Because there's some more view graph stuff coming up. Maybe we could have this guy removed so that people can see it again. Lynn, my goodness. Are you going to
unplug it, George?
Yeah. Thanks very much. All right, let's snap onto the view graphs again, and I'll try and wrap this up. As I said, we have confirmatory evidence that confirms that something unusual is going on. The ones that I put a bunch of these on a view graph, and they're not quite as neat and clean to see as the ones the original photos, and I have the original 8x10s from the scanning electron microscope at U of T, which you see here, and you can take a look at them, and they're much easier to analyze. But I put them up in view graphs so I can discuss them. This on the left is an aluminum specimen, only about 70 times multiplication or magnification, and the whole surface has been torn up as if it was gouged randomly by some mechanical means. And this is in its rough shape. It's not been smoothed and polished and subjected to X-ray or dispersion analysis yet. A piece of iron is on the right, and it was used to take a look at the composition, and there's a bunch of copper that comes out and is shown in a big band right along here, although it's not visible there. At a little higher magnification, we see what happens in a polished aluminum sample under the SEM. The fracture zones are here and here. Here are two of them. This is a polished sample. That's why this is all looks nice and clean. But we get globules forming, and we took a look at these particular globules, and they are virtually purely elemental. One's copper, and one's manganese, and one's something else. And there are similar kinds of these globules which seems to arrange themselves along planes, and these planes are no doubt the ones that split apart and delaminate into those funny destroyed samples that you've seen. Normally the aluminum comes out looking like this if you scan and do an analysis, spectral plot as it's called here, of the percentages over a reasonable area. The average is mostly aluminum, of course, with a bit of, mostly a bit of copper in it, as it says there. And yet, at the end that's blasted, that's at one end of one of these samples. In fact, I don't know whether you can see it, but this is one of the samples that I showed you on the slide. That one shot, that one spectral plot is from the bottom end. This one that I'm showing you is from an area around where the fractures occur. And we see we've actually located one of the copper blobs. Hold it, pardon me. And we've got a lower aluminum content, some chlorine from our fingers. Usually you see some chlorine and sodium from salt in your hands if you're messing around with these things. Manganese, yes, iron, bit of iron, and then this huge copper peak, the first and second copper peaks. So certainly telling us that something unusual is happening. I'm not a metallurgist, and maybe some of you in the audience who have some experience with that can tell me that this is something that happens all the time. Maybe it doesn't happen all the time. I've not seen something that appears to, an apparatus which appears to make the alloying material in an alloy come out of solution. Usually it's just dispersed in the melt. But in this case, we're undispersing it magically somehow. The first setup. This is the a plan view of the lab that you saw me walking into, you walked into with me in that first video. We walked in the door here, and the main tuning control was down. We panned down, and there was a little red box on the bottom. Van de Graaff generator, as you can see all these things. Field shaping unit, which was basically an elevated aluminum sphere about 11 inches in diameter. Large Tesla coil, the one I showed you is there. There's this dumbbell coil, which is suspended from the ceiling, a double-ended Tesla coil with toroidal primary, if you can figure that one out. Transformers and spark gaps along here, that tremendous mess of junk that was in the corner. Amongst the junk was the essential ingredients, which were 15 kilovolt neon sign transformers and things of that nature, a few of them. Large masses, large steel masses all over the place. There was, in this case as well, a in his first and most effective experiments, a 400 kilohertz continuous watt, or pardon me, continuous wave generator. It was just basically a radio transmitter, a low-frequency transmitter that he had switched on for CW operation, and it had a 3-foot whip antenna. Later, he replaced that, probably because it broke, with a small Tesla coil here, which I scanned very briefly in the video, which is about 3 feet, about 3 feet off the ground, and it's about 1.5 feet high. In between a lathe and another lathe, he has a plywood platform upon which most of this apparatus, most of these specimens flew off. I'll get into more details with the second outline. All this will be in the proceedings, by the way, for those of you who are busily scratching down the thing itself. Now this is a lab that we set up in 1983 to try and attract some more funding, and I personally put this one together, trying to pick the bits of the apparatus out and assemble them myself. And that is the lab from which a number of these samples came. Spark gaps and tank circuits and things like that along this wall, a main power supply which has a couple of neon sign transformers. There's a 21 kilovolt transformer there from a Picker X-ray machine which powers a number of these spark gaps, all at 60 cycle rep rate. The gaps are, there's this double-ended Tesla coil here suspended from the ceiling, a large Tesla coil there, field shaper thing, Van de Graaff, Tesla disruptive discharge, which is basically a double-ended iron core transformer, and the small Tesla coil over at this end. Now, this distance is approximately 12 feet or so between the large Tesla coil and the small Tesla coil over here. Between that is what is called the active area, and that's the area on which it's just basically a platform on which we put objects of whatever material we wish and hope that they'll fly up to the ceiling or burst apart or whatever. And he calls the main tuning control is up here, which basically consists of a bunch of high voltage variable capacitors and variable inductors. More precisely, where is it here? Now I have these, I believe I have the shots this is from, but I'll, for the benefit of those who weren't able to pick up all the details in that film, I'll go through a bit. This is the second lab, the one that I set up in 1983. You notice it's rather messy. I tried to set it up exactly the same way that John had set it up. And so I didn't make nice connections, things like that. I wanted it to be just the same as what he had done, except I tried to use a minimum amount of components. The large Tesla coil is here. It's 4.5 feet tall secondary, multiple, a few thousand windings of number 27 or 30 or something like that, enameled. It has a toroidal coil of about 12 gauge on the top, or resting near its top, another loaded coil here, and what you can't see up the top is about an 8-inch copper ball. There's a 50-turn primary, about 10-inch diameter down here, and there's a ring right that goes around this thing, the bottom, or pardon me, at the top end of the primary. This field shaping unit, which you saw, is here. It's basically a ball with a hat on it, kind of an annular hat. It's a ball of aluminum. There's the Van de Graaff up here, which is about a 250,000 volt DC maximum. It's about 11 to 13 inch diameter ball. I can't remember exactly what the dimensions are. there are various and sundry tuning capacitors. You can see high voltage transmitting caps, very low capacity, and RF coils here and there. And the top here, you can see this double-ended Tesla coil along the top with its electrode, one here and the other there. And here's this, as I say, a double toroidal primary. And in the background is all sorts of more coils and capacitors and things like that. Hidden down below, out of sight, is a spark gap, gap that snaps every so often, and about every 40 seconds or so. And in the back corner is the Tesla coil. You can just make out that white line. It's a double 807 triode Tesla coil, which has a nice spot frequency of about 760 kilohertz. The large Tesla coil, when it's powered, is somewhere around 330 kilohertz. And let's see, here's another view of a later setup. Pardon me. So you can imagine it's hard to tell which is right side up here. There's John himself in a lab that was in early in '87, and which was filmed by a television crew and was shown on the national news. A couple of things lifting up, and which you may have seen. I don't know whether Electra, you have that copy in your archives. That was John and the setup that was used, or that's John. And here is this is John's lab before he tore it apart. Unfortunately, it's difficult to see in a view graph, but there's the large Tesla coil is up here. There's the Van de Graaff there, the dumbbell double-ended Tesla coil there. This is shown to you merely to suggest the size and scale of the devices which you're working. There's no way one can take this information and do any calculations on it. In general, a block diagram consists of following four components, one of which is missing from this diagram. Van de Graaff by itself sits here, and it goes through a gap and a capacitor. The gap is never firing to ground. The small Tesla coil is sitting there by itself, just as a normal Tesla coil would, a little experimental Tesla coil, powered all by itself. Same with the Van de Graaff, all, by the way, powered from this 15 amp, 110 volt supply. The interesting stuff, this field shaping device, dumbbell coil and its two primaries, a high voltage supply roughly here. These are air core transformers. These guys here, those are the toroidal transformers that you may have recalled from the video I showed prior. Various tank circuits and tuning circuits, this disruptive discharge coil here, and the large Tesla coil there. What's missing is a gap about 3/8 of an inch wide, which is powered by a 15 kilovolt DC supply through a capacitor, and it just snaps every 40 seconds or so. It gives a great blast. There's no time correspondence between the snapping of that gap and objects taking off or dismembering themselves or whatever. I do not know, do not know the function of any of this apparatus in producing the phenomena that you saw. And one of the prime reasons I'm here is to suggest that you think about it, if you wish to, and help me try and understand what is going on. Because I do not know the mechanism whereby this assemblage of components causes objects to lift. I certainly can come to some reasonable conclusions and explanations as to why this assemblage of apparatus causes things to burst apart. That's much more understandable to me. What is not understandable is how this causes objects to lift. And for those who are really keen, I can describe this in this block diagram in more detail. I think that just had mentioned some of the field strength readings that we have taken, which some of the results are here. It looks like I'm going way over time. This is a magnetic field taken by with a field strength meter on an 8-inch loop, a vertical loop. And I'd like to say it's purely magnetic, but I'm sure the apparatus that we're using was left a bit to be desired. In any event, you see the standard 60-cycle rep rate bursts. This is these two shots are a standard scope reading, time trace, and there the standard bursts is the gaps fire and a classical kind of Tesla. Or messy Tesla decaying waveforms. And then we have spectral analysis down on these four. The small Tesla coil by itself has a little sideband, but its main peak is at 760 kilohertz. The CTR is a center frequency for those who know spectrum analyzers. Center frequency 760 kilohertz, dispersion 10K, and the vertical scale means nothing really. That's the small Tesla coil. The large Tesla coil is shown below, center frequency around 350 kilohertz. A very messy, noisy spectrum, and the reason is because the large Tesla coil is not powered in the normal way. It is powered merely inductively. It's something I can try and explain to those who are interested. There's also a peak around 610 kilohertz, which is probably a sideband of one of these guys. This is with everything, all the apparatus on. And here's a center frequency of 300. This is probably from the fluorescent lights. We try to do a scan from the low frequency right up to high frequency, and this is what we got. That was it. Field strength measurements. And I apologize for the format of this. I didn't have much time to throw together these things. But based on a field strength reading of about, we have a relative field strength reading of which I have imputed a strength in microvolts per meter up to a scale going up to about 7,000 here. The solid line indicates the measurements that we had taken, and these are in feet. This is distance from the center line away from the apparatus, from the center of the active area, about 50 feet. And the solid line represents measurements that have actually been taken, and the dotted line, a 1/r² line, just to put up and show. So there's nothing really very unusual there.
Can I interrupt you of that graph?
Yes, Tom.
Are you actually telling us that you only have 2,000 microvolts per meter as the peak
Yes.
E field? I think that's pretty amazing. I expect at least kilovolts per meter.
No, the maximum, if we extrapolate that curve up, we've got about 100,000 microvolts, or 0.1 volt per meter, right in the center of the active area. Now, I should caution, this is when the apparatus was not working to full potential. Whether indeed, when things happen, big major events happen, the field strength goes way up, I'm not sure. But this was a normal run where a few things were happening, some slight things were happening to make sure the apparatus was functioning, but nothing major was occurring. Certainly nothing major can be seen from this.
When you say way up, how far up do you mean?
I beg your pardon?
When you say way up, how far up do you mean? How many volts do you mean?
I have no idea. We were not able to have the apparatus at the same time we had. The question was, what do I mean if I say the field strength may go way up? We did not have the apparatus, the field strength meter, at the time when the best lifting was taking place or disruption was taking place. Therefore, I cannot tell you what the field strength would be when, the electric field strength would be when the major phenomena was occurring. I could only imagine, based on engineering principles, that it would be much higher than this. Does that answer your question? That's all I can do. That's correct. Something that I have a little more control over is an analysis of the lifting capability. And here is a strip of the 8mm film that I had blown up and did some analysis on. And this was, as you can recall from the film, one of the last things you saw in the video, which was that 19-pound bronze bushing taking off in slow motion. These are the shots from it, and it's just an initial cut at the kind of trajectories we have. This was what I considered a powered takeoff, and it's confirmed by the measurements. I measure the distance between the bottom end and the bottom end in a zero in its resting position, and the bottom end when it actually leaves the frame, and plot that.
Put that back on again.
Certainly.
Look at the right-hand side at the series of patterns that you are seeing there.
That's, yes.
That is important.
Now, but just a second. Are we talking about these patterns here?
Yes, sir.
Yeah, that's the pattern of the milk carton on which this...
Is it a milk carton or is it a reflection from that surface?
No, that's milk carton. I'm pretty sure it's milk carton. If you wish me to run the video again with this particular segment, I will, and we can confirm that.
Because if it was a beat wave, you would have a very valuable bit of information.
Yes, that's true. We also have another valuable bit of information that some of you may have caught in the length of the breaks of the file. That gives us an indication of some kind of wavelength that can be translated in frequency, but still nowhere near the kinds of things that I would expect, kinds of frequencies that I would expect to be required to do any of this. But that's a good point. One should always analyze the spatial distribution of things, breaks and others, for clues as to the kinds of operating frequencies. If we plot this, and derive an acceleration versus time graph, this is acceleration versus time graph. I do not, in this graph, I do not have my error analysis, so I'm sorry I can't give you a standard deviation on some of these points. But the result is that there is a non-flat acceleration curve. There is power being provided to this object, whatever it is, pardon me, whatever the power is, it's the 19-pound bushing, by the way, that's going up, constantly. There's constant power propulsive power being applied to this, as witnessed by this increasing acceleration curve. And these are the measurements up to, from here to about 0.16 seconds, and then beyond is an extrapolation. And there's the acceleration equation there. The minus 9.1 is merely an artifact of my measuring problem, analyzing that film strip. So to try and finish off, in fact, I think what I had better leave the discussion of how this thing works and the theory behind it to maybe a question period, because I am at sea, literally, in trying to determine how this device can provide a lift. And that's what I hope to perhaps glean from you folk. And I mention a few names here that might have something to do with an explanation of it. And finally, a few potential applications of this thing if it can be produced in such a format that it's repeatable and controllable rocket payload assist, materials handling and warehousing, floating things into position, materials handling of hot objects, objects that are highly radioactive or something of that nature, forging and casting, extruding of metals, alloying, power production, conversion, etc. Defense applications with a strange spelling. So that wraps up my contribution, rather disparate group of things that I had to show you, but this is an extremely difficult technology, if you call it, or effect, to wrap one's mind around, as you can see already. I have had a great deal of difficulty in convincing scientists to think about this possibility, let alone try and provide some mechanism for its operation. And I hope that in meetings such as this, I'll be able to engender some interest so that people will think about it. Perhaps they will go home and, if they have some equipment, do some experiments as well. I must caution anyone who is interested in pursuing this that this is an extremely dangerous apparatus, if you haven't figured that one out already. It's never knocked any of my fillings out, but it certainly has the potential for doing so. It has smashed mirrors in one of its incarnations 80 feet away. It has overturned a large metal object of about, I guess, 50 or 60 pounds, about 100 feet away. And its effects can't be pinpointed unless we're lucky. We try and find the active area, and then we hope that something will happen. But perhaps something very far away will happen. Something over there will happen. Something somewhere else. The apparatus is capable of starting fires anywhere. It will start fires in concrete, if you can believe it. Little bursts of flame here and there, and it will cause your mains circuit to have problems. We've blown fuses out hither and yon, and circuit breakers and large lights and things of that nature. It also tends to destroy itself, and one of its a classic case of that was when we had some high-power types up looking to help develop it. In the morning of its being shown, it blew one of its own transformers apart, and so needless to say we didn't do a successful demonstration. So I will stop now and entertain questions from the floor, I guess, at Andrew's discretion. Is Andrew here at the moment? And if not, how long do you think I have here? It's 10:33. Lots. Okay. Thanks very much for listening.
I'd like...
Marcel.
Yeah. Congratulations. I find it exceedingly exciting and interesting. I too have experienced the generation of power like this with a crystal. Just a single natural quartz crystal cut in a special form. I've generated fields which have knocked out electrical equipment and generated power which have destroyed matter. Now, my suggestion to you is do specific gravity measurements on the plugs of metal on the beginning and the end of the specimen. What I think is happening is there is interlattice vibrational activity going on. Namely, you are stimulating the lattice motion, and when it gets to a critical space, the lattice collapse. And then you get this stratification that is characteristic I saw in a series of metal samples. They look like they were leafing in the aluminum and metal. That should be critically studied. It's a very, very important thing that can help you to understanding.
You're suggesting specific gravity measurements?
Absolutely.
Okay, thank you. Jacques?
Was there ever any of these effects while John was not there?
No, none of these effects have occurred, none of the large effects have occurred when John Hutchison, the inventor, was not there. We had, when I set the lab up, the second system there, we had some minor occurrences when I was personally adjusting the setup. But these were, I can't suggest that these were the same kinds of things that you saw, because they could easily be blamed on merely electrostatics. And anyone can do lots of funny things with electrostatics. They were rather unusual, but I cannot claim to have seen anyone else, including myself, make the apparatus work. And basically that turns into have the patience to sit with it and adjust it without John being there himself.
Roughly, what is his background? Did he study, or how does he think of doing this?
That's a good point. John has a high school education. He does not have any formal electrical or university training. He has been experimenting with Tesla coils. In fact, the way he stumbled upon this was he was trying to duplicate Tesla's transmission of electric power without wires, hence the 2 Tesla coils. And he happened to add, on the suggestion of friend Mel Winfield, the Van de Graaff generator. He cannot explain these things in terms that that people who have had some training in these fields like to explain things in. He talks about energy fields. He talks about energy moving around and being transported from one place to another. He talks about interactions between energy and gravity. That is the extent to which he can explain what his understanding is to you and I. He has an incredible intuitive capacity to follow the flows of energy that he is trying to manipulate. Something far beyond me. I have no concept of the kind of understanding that he has. He's been at it since he was about 6 or 7 years old. Continuously. He's on a government pension for this problem, and he has a lot of time. And time is necessary to develop this kind of technology, this specific kind of technology, if you are not concerned about particular results or getting somewhere. Unfortunately, most of the rest of us don't have that kind of time, and we want to produce something that is tangible, something usable, something that we can develop into a useful product. That is of very little interest to John per se. He's interested certainly in getting the technology moving, but not at our pace. And that has been one of the causes of having this thing sitting in the background and waiting for some time and taking a long time to develop. So he has a good intuitive feel of what's going on. He can't explain it in words that you and I would understand. And he's been at it for so long that it doesn't matter, really. He has no need to converse with us in those kind of terms, and I doubt that he could. There's the microphone. You'll have to join up. Dr. Aspen.
When I get back to England, I've been greatly impressed by this, of course. It's incredible. I would not have believed, this from a distance, but it's great to see the demonstration and have the confidence now that this is a real effect. But my first reaction is that I would want to look at the breaking of these specimens with an eye to what is called the exploding wire phenomenon. This is where you pass very rapidly a very high current through a very thin wire, and it breaks up into very tiny millimeter sections as if it's been chopped up with no evidence of melting. That is a phenomenon being studied by Peter Grano particularly, and that should be considered in regard to this rupturing process. But I cannot escape from the fact that there must be some evidence, there must be some action of ether in this activity. And I think the relevance of the tornado to this is of very great interest, because there is evidence of patterns in fields, circular patterns in special groups that have something to do with the magnetic field that are created, and that to me is evidence that you can get some kind of vortex or spin in the ether itself. And I would look at this phenomenon as perhaps arising from the induction of filamentary vortices and spins, which tend to pull up these specimens into line. Now, having said that, suspecting that, there's no way I would ever go over a cup of coffee that's vibrating with a camera just above it, because my poor head gets in the way of those things, and I'd be very scared to go anywhere near that type of activity. And so I am a bit concerned that you can have all these things happening and then move in with a camera to take those pictures. How close did you dare go to the real center of activity?
Well, first of all, I'll preface my answer with the fact that I have, since filming this at close range, I have sired a very healthy child, a beautiful girl. And so that hasn't affected the somatic tissues. But we were within 6 to 8 feet of it. John respects his apparatus when it's going. He will not enter into it. He knows the limits of it, and he tells us what the limits are, and we stay without those limits. I suffered a severe migraine headache after my first two encounters with it, but I cannot attribute those directly to the apparatus themselves. I was so excited after seeing this thing work for the first time and the second time that my mind was going at 1,000 miles an hour, and that is what I generally attribute my headaches to. John, on the other hand, has complained of microwave clicks deep inside his head after the microwave clicks are a phenomena that has occurred in radar technicians, high-powered radar technicians, where for some time they have clicking sounds deep inside their heads. John has complained about that a small amount, but he has not complained about any major effects. We perhaps have just been lucky, or perhaps somehow he's been protecting us. I don't like to bring up the PK end of all this, but it certainly may be relevant. Regarding Peter Granot's work, I have discussed this with him, and he is aware of what's going on somewhat, and he's very interested in following it up. And as regards to tornadoes, something as well that might be relevant is there is film evidence of the fact that tornadoes have very interesting electromagnetic phenomena going on inside them, bodies levitating, going up and down very slowly in the eye of a tornado, and emitting showers of sparks and things of that nature.
May I add one more thing, please, as a word of caution? A weak force, as just taking water and spinning it around a crystal in the wrong direction, I did but once in my life in 1984, and I was flung 10 feet away from the experiment against the wall, and the next day my face was burnt as if from exposed with intense radiation. My eyes were closed. It was witnessed by 5 feet. That was only letting 100 cc's of water spin around a crystal that was charged. So you must proceed cautiously with these forces. I speak from experience.
There certainly is a requirement for that.
Just one comment. First of all, let me explain that I am a zero physicist. I know very little. I mean, I've had conventional university training in physicist, but I'm essentially a biologist. And I'm specially interested in the energy fields of living things. Now, the phenomena, I came in rather late in your talk, but the immediate thing that struck me about your talk is that the phenomena is very reminiscent of poltergeist activity. Now, I don't want you to begin to think mystically as soon as I say this. I myself see a lot of poltergeist activity as a direct result of intense and disturbed energy fields in people living under specific circumstances. Now, the fact that you mentioned that this phenomena is seen only in the presence of this man, and that this man has been working on this from a very early age, implies to me that his organism has a specific need in this regard. I can tell you one little experiment. I've done work in relation to the energy supposed to come from the hands of so-called healers. And this is a little experiment in which a healer, this was told to me, I had never seen it, a Polish healer presently in America, was doing a healing in front of an audience. Standing to his side, the audience was facing him, standing to his side was his wife sitting at a table such as you are with a microphone. The healers say was there. His wife was sitting in front of a microphone there. Over on the side of there was a generator. This was an unusual situation in the sense the generator was there. While he was healing, to the surprise and astonishment of anyone, a waveform appeared directly to the motor across, to such an extent that it frightened and astonished everybody. But she was able to, the whole thing was able to be dampened as soon as he stopped healing and as soon as she turned the microphone away. I just want to put some focus on this direction. I think these are very interesting phenomena. By no means mystical phenomena, I want to emphasize, but phenomena that can be investigated scientifically. I'm not at all surprised that he's a person who's never had formal education, yet constantly speaks of energy fields, which is, by the way many healers and so on speak. Thank you very much for your...
As a one rejoinder, we had considered that kind of approach and the PK, or psychokinetic approach, as a possible explanation as well. We tended to downplay that for a number of reasons, including the fact that John was very excited about two particular demonstrations we were going to give for rather high-powered investors. And on both occasions, the apparatus, as I say, failed. Now, one could say that there was some kind of negative influence, that John was just his one unconscious side was fooling his other unconscious side and saying that he was not going to proceed with this. So, but he certainly was excited and he wanted to get going. However, that's not always a facile approach.
A dowser or healer fails, maybe so, especially when there's a prospect of being able to get money.
Yep.
One point, my wife and I are in touch with John Hutchison regularly, and we have a large archive of his information, and he has stated that he does not wish this technology to be used for any destructive or military means, and that he has kept certain information so that it will not be able to be used by other people, and this may be one of the reasons why no one else has been able to replicate exactly what he has done, because he has not told anyone everything that he is doing. So that was one point I wanted to make, and that may be why no one else has been able to replicate this.
Oh, God. Have you tried to selectively isolate components in the electrical equipment so as to pinpoint whatever might be the cause of this?
We were going to embark on a program of doing just that in our last phase of work, in 1987, the beginning of 1987, but unfortunately, the things fell apart contractually with John, and we were not able to continue that research. John has an interest in putting more things together